We will cover this concept of the hydrophobic core and hydrophobic effect in more detail, including quantifying it with actual numbers on the delta H, delta S, delta G terms in chapters like 7, 8, 9 area, okay? But for now, more of a qualitative understanding. That's what I'm looking for, okay? Driving force in protein folding is the formation of this hydrophobic core, okay? And another name for this phenomenon is hydrophobic effect, something you're probably familiar seeing oil and water and that separation. Hydrophobic effect is the observed tendency of nonpolar substances to aggregate in an aqueous solution to exclude water molecules. So hydrophobic things trying to get away, associate with each other, and stay away from water if possible. And this is sort of the primary effect that underlies protein folding, okay? So in this particular case here, we have some unfolded peptide or protein chain, and here are all its side groups. We have some hydrophobic structures or apolar structures are shown in yellow. Again, you don't need to memorize the colors. I tell you what was what on here. And the other stuff is sort of our polar stuff. And so when this thing folds up, it's going to create a core. Here it's showing a beta sheet or an alpha helix, maybe a loop region. It's going to tuck all the hydrophobic stuff inside and put all the hydrophilic stuff on the outside to continue interacting with water. Okay. How come hydrogen bonds and not the hydrophobic core? How do I want to phrase this? How come the hydrophobic core is the driving force for folding and not hydrogen bonding? In this situation here, do we have hydrogen bonds? Where? Between water and polar groups. In this situation, do we have hydrogen bonds? Polar groups in water, and where else? In the backbone. The backbone's making its own hydrogen bonds. But what we don't have here in any way is hydrophobic interactions. Maybe some of these are doing something nearby. But for the most part, we're creating a whole bunch of hydrophobic interactions that we did not have before. Okay? And that's sort of what's being illustrated here, is that when it's unfolded, there's maybe some hydrogen bond with water. And then once we fold up, we'll just make hydrogen bonds within the backbone. Okay? This is another spoiler, might be related to a homework problem. Kind of something going on here. The net contribution to making a DNA double helix from hydrogen bonds, not very much, okay? Because here you have H bonds with water, here you have H bonds with base pairing, but the net difference in H bonding, not significant. What you have new in this situation is what? Base stacking, right? These van der Waals interactions. And that's similar to what's going on here, that once you fold it up, you can have hydrophobic interactions in the core.